Hey guys, it's Landon with RH and Taught by a Surveyor. This is the third video that I'm doing in the set of videos about error management for land surveyors. Even if you're not a land surveyor, this set of videos will teach you a lot about some basic probability and statistics. So it's helpful even if you aren't going to be a surveyor, although I highly recommend that as a career option. So in this video for the set, we're going to talk about best fit versus average. So that's a question that one of my survey techs, Nikki, she asked me, what's the difference between a best fit value and an average value? There you go. Nikki, there's your shout out. So that's what I'm going to teach you that in this video, I hope. That's the goal. So why do we care? Well, we care because we use best fit values and average values to approximate the true values of a measurement. So surveyors can never find truth, but we can estimate the truth. So we estimate the truth with average values or best fit values. Those are the main two ways. I can't think of a third. If you're a surveyor and you're watching this and you think of a third way we estimate the true values of measurements, please let me know. Okay, so we do best fit and average, and we care because we want to know what the true value of measurement is as closely as we can tell, because it's part of how we estimate how good our measurements are. Okay, so you can't estimate, I shouldn't say you can't. It's difficult to estimate how good your measurements are if you don't have an estimate of the true value, so that's why we care. So let's talk about the two types of estimated true values. We're going to talk about average values and best fit. Then we'll talk a little bit more about what they call in statistics measures of central tendency. So the average, and probably the best fit too, they are measures of what we call the central tendency in statistics, but there's others. But these are the two that we use in surveying most often. When I say central tendency, in other words, we want to know, if you remember the bell curve, by the way, if you didn't watch video 1 and 2 in the set, go do that. But if you think about the bell curve, that black line I drew in the middle that represented the zero error, that's the center of the bell curve, right? So there's other measurements we use to measure what that value at the center of the bell curve is going to be. It's called a measure of central tendency. In other words, what value do we think tends towards the center of the bell curve? Okay, so let's talk about averages for a minute. And even if you learn this in elementary school or grade school, I'm gonna teach it to you again anyways. So let's say we're measuring a distance that's 100 feet, and we've got my measuring wheel. Remember, it measures to the nearest foot. So we're rolling it over the ground. Maybe it's grass or some gravel, and it's bumpy, and so we don't get the exact measurement. We don't know it's 100 feet when we measure it, okay? I'm telling you with my super X-ray surveyor vision that the true distance is exactly 100 feet. But we don't know that when we're measuring it with a wheel. Okay, so we go out and we wheel the distance 10 times. And these are the values we get. Okay, 98, 98, 99, 100, 102, 100, 98, 99, 101, 101. Okay, so if we want to know what is our best estimate of the true length of that line, what we can do is we can calculate the average. That's one estimate of the true value. So to do that, if you remember from school, the average, you take the sum of all the values that you've measured and you divide it by the number of values. That gives you the average. So we've got 10 values. So I'm going to add these up. First, we're going to sum them. So 98 plus 98 plus 99 plus 100 plus 102 plus 100 plus 98. By the way, this is it's really handy to have a reverse Polish notation calculator. For all you HP fans, I'm using an HP 50 here. Okay, plus 99 plus 101 plus 101. Okay, so I got 996. Okay, so now I'm going to divide that by 10. Okay, so our sum, I'll just write it over here. Our sum, let me do it in a different color. Our sum was 996. Okay, and I can gut check that. I know I've got 10 values close to 100. I should be close to 1,000, and I am. So we're a little bit short. So remember, I told you random errors tend to cancel, but they don't always cancel. So I'm 4 feet short here of 1,000, which means when you add up all the random errors, I ended up a little bit short of the true answer. So they didn't cancel out exactly. By the way, I just pulled these numbers out of my top of my brain. There's no conspiracy here. These are pretty close to randomly generated. Okay, so 996, we divide that by 10 to get our average. Okay, now you got to decide when you're doing this kind of math to what number of significant digits do you want to put your answer. So now it would be silly to do something like this, 996,000, and say, oh, well, that's the true value. We only measured to the nearest foot. So at the most, I'd be comfortable with that, right? And probably what we need to do is round up. So if we go from 99.6 and we round up, we get to 100. Now what you'll notice is that's also the true answer. That's why we use average. It's a pretty good estimate of the true value if you have a normal distribution, if you have a bell curve, right? Now, I didn't plan that. I just tried to randomly generate some numbers pretty close to a bell curve distribution, and I did a good job because the average is 100. Okay, now for this kind of distribution, the average works really well, and the best fit value is going to be very close or exactly the same as the average. Okay, so let's talk about a best fit value. What is a best fit value? Okay, in a best fit value, you basically pick a value and you calculate your residuals and you iterate. It's called iteration. We iterate, we choose different values up and down, and we try to see, is there a value, what value makes the residuals the smallest? In other words, what value fits the best? Okay, now, we use computers to do that because it's a little bit labor intensive, but I'm gonna just walk through the example here. So let's just say, now, if we were gonna design this, and we might code this up in Python, just a tool that does this, that compares the average to the best fit. But if I was gonna code that algorithm, I would probably start with my average value. So let's start with our average value, it's 100, and let's just plot our residuals here so you can see what I'm talking about. Okay, so our residual here, we're down to, right, 100 minus 98. Down 2, we're down 1, we're at 0, we're up 2, we're at 0, we're down 2, we're down 1, we're up 1, and we're up 1. Now, one thing you got to do with best fit usually is you got to get rid of your signs. So we're going to get rid of these signs. We're just going to take the absolute values because we don't want our signs to cancel. And now what we're going to do is we're going to say, all right, if we add up, we're using the value of 100 as our best fit, we're going to sum these residuals and see what the number is. So we got 2, 4, 5, 7, 9, 10, 11, 12. Okay, so the sum of our residuals, whoop, I have a hard time right when I'm that low on the marker board, is 12. Now, when we iterate, what we do is we pick some interval and we go up and we go down. And we say when we increase or decrease the best fit value by that interval, does the sum of the residuals get smaller or bigger? If it gets smaller, it's a better fit. If it gets bigger, it's a worse fit. So let's just do that. I'm going to add a column here, and we're going to say, all right, so this was with a best fit value of 100, which was also our average. Okay, we're going to say, all right, with a best fit value of 101, I'm going to go up 1, and then I'm going to go down 1 with 99, and we're going to calculate the residuals. Okay, so we got 3 here. Okay, we're just going to do absolute value. 3 here, 3 here, 2 here, 1 here, 1 here, 0 here. Nope, sorry. That's 1. Apologize. 1, 3, 2, 0, 0. Okay, now we're going to sum those up. We want to know, is that bigger or smaller than 12? So I got 3, 6, 8, 9, 10, 11, 14, 16, so 16. So it's actually quite a bit bigger than 12. This number is not as good of a fit. Let's try 99. Okay, so 99, we're going to do the same math. We got a residual of 1, 1, 0, 1, 3, 1, 1, 0, 2, 2. Let's sum those up. 1, 2, 3, 6, 7, 8, 10, 12. All right, so interesting. So 99 is also a pretty good value using the best fit method, right? It gives us the same residuals. Let me just double check. I want to make sure I got my math right. 1, 2, 3, 6, 7, 8, yeah, 10, 12. Okay. All right, so either one of these, so in other words, with the best fit method, both of these are equal. Okay. All right, now, you don't have to iterate very much. So we could do that again. We could go with 98 and 102, but you would quickly see that our residuals start to get way bigger. So that's how best fit works. It's like an average, but we do it in a computer because it involves a lot of little math steps, a lot of little calculations. But it's not that complicated, is it? I mean, it's pretty simple when you think about it this way. Now, I will tell you that the best fit method we use most commonly as surveyors is called least squares. And the reason they call it least squares is we don't use the absolute value of the residuals, we square them. I don't know why. Somebody decided that's how they were going to do it. And so that's what we do. But the concept is the same, and I'll do a separate video and we'll do the same thing with least squares. Now, are there situations where a best fit value gives you a better solution than average? Yes. Okay, so let's see if we can come up with some numbers that do that. So I'm gonna make a couple of these values. I'm gonna make a couple of these values fairly. I'm gonna give them a fairly large residual. Okay, and then let's see if we can get this to work. All right, so let me add these up real quick. Okay, so I've got 1007 now is, I'm sorry, yeah, 1007 was my sum. So my average of those measurements would be 107 if we divide by 10. Okay, so let's just run a best fit here. Let's run a couple best fit tries. So we're going to start with 107. What I want to see is, do we get a best fit value that's better than the average? So the average is 107. So let's just do this math real quick. So we've got, let's see, that'd be plus 9, plus 9, plus 8, plus 7, plus 5, plus 7, 3. You know what? I did something wrong with my math. It can't be 107. Sorry, guys. 107 is bigger than all the values. So obviously I didn't do that right. Let me try this again. I apologize. At least you guys know I do this live for real. So let's try this again. 98, 98, 99, 100, 102, 100, 104, 104, 101, 101. Sorry, it's 100.7. Okay, so 100.7. So if we round up, it's going to be 101. That's the average. Okay. All right, sorry about that, guys. So let's try that as our best fit. Okay, that looks a little better. So we got 3, 3, 1, 1, 1, 1, 3, 3, 0, 0. All right, so that's our residuals. Add those up. We got 6, 7, 8, 9, 10, 13, 16. So we got 16. Okay, now we're gonna iterate. Now I'm gonna go up. I'm gonna iterate up because I know I put a couple high values in here. So I'm gonna say, what do we get with 102 as a best fit? That might be a better fit than the average. Let's see. So we got 3. Nope, I'm sorry. We got 4. 4. Let's see, 3. You know what? I messed up. That should have been a 2, guys. Sorry. So that's 17. Let's see. We got 2. We got 0. We got 2. We got 2. We got 2. We got 1. And we got 1. Okay, so let's sum those up. We got 8, 11, 13, 15, 17, 19, so 21. Okay, so doesn't look like 102 is a better fit, right? If I did my math right, let me just check. 1, 1, 2, 2. Okay, so let's try. Let's just, for kicks and giggles, let's go down. Let's go down and do 100 and see what we get. So it may just be that I picked a couple examples where the average is also the best fit. So let's just try this. We got 2, 2, 1, 0, 2, 0, 4, 4, 1, 1. Okay, so let's add those up. Oh, now it looks like a 3. Boy, I really messed that up. Okay, so we got 4, 5, 7, 11, 15, 16, 17. All right. Okay, so in that case, we have a best fit value that is at least as good as the that's at least as good as the average. I'm just curious if we went 99. I think it's going to get higher if we go 99. Let's just do it. Let's just do it just for kicks. And then if you're a surveyor and you're watching this and you understand when a best fit value gives you a better answer than not a better answer, but is a different answer than the average, if you let me know so I can simulate those values and teach the kids that. Okay, so we got, let's just try 99 as our best fit. So we got 1 for our residual. 1, 0, 1, 3, 1, 5, 5, 2, 2. Okay, add those up. We got 1, 2, 3, 6, 7, 12, 17. So that's going to be 21. Okay. So in this case, our best fit values. So 101 is the average, and it's also the best fit, right? We got another best fit at 100, right? That's pretty close. That based on the sum of the residuals. So you guys understand how a best fit works now compared to an average, and you can see why most of the time we use the average, because most of the time the average is a pretty good answer. And when you deal with statistics, they're almost always using the average. They're not using a best fit. Now, one advantage of a best fit adjustment versus an average, and this may be why we use it, is you can do what they call weighting in a best fit. So you can weight your measurements, and I'll do another example where we talk about weighted measurements in a best fit adjustment, because that's also important, and you're going to see that too when we get into TBC. You can, if you're mixing different types of measurements, static, RTK, total station, you can weight those differently in your adjustment. Okay, so don't forget, there's more. There's other measures of central tendency between, besides average and best fit. There's the mode, the median. There's probably a couple more I'm not thinking of. But the median is the middle value. The mode is the value that occurs the most number of times. So there's other measures of central tendency besides just the average and the best fit value. All right, thank you for watching. We did do a little math on that, but it was just arithmetic and a little bit of division. It wasn't too bad. So you can see, error adjustment doesn't have to involve a bunch of calculus. and we can get computers to do a bunch of this math for us. We'll actually code a little Python tool that calculates the average value and the best fit value and shows you the comparison. I think we could whip that up in Python and Tkinter pretty quick. So I'll try and make time to do that in the next couple of weeks, and I'll release that code. We'll release it open source so you guys can tinker with it. And thanks for watching.